Hey there folks, how you doing? Today we're going to talk about streams. Um, Streams are awesome, streams are great, we love them. We like to look at them, we like to live near them, we like to maybe drive over them on big bridges, we like to go down them in boats. But in a geologist's mind, they are an earth scientist's mind, um, an engineer's mind. They are nothing more than surface water drainage systems. Okay, they're a ditch with water in them, but they're still pretty. So, hold on a second. I'm going to try and rearrange the screen capture image here. Okay, well, hopefully I made it a little higher here. You can see the word stream now at least. A stream is any channelized body of water regardless of size. All right, we talked about what it means to an earth scientist or an engineer. This is really what it is. And the big thing is we can't get bogged down in whether it's a river or a stream or a creek or a crick or a brook or any one of the other handful of terms that we use for flowing water that generally imply how big it is or isn't. All right. So in order to get rid of just all that stuff, we just use one single word, stream. And that sometimes causes some confusion when we do the topographic mapping lab where I have you guys look for, I say, find a stream on the map. And you're like, well, I can't find a stream, but there's this river here or there's such and such creek. I don't even think about it. And even though I give this lecture every semester, um, that's what I meant, I guess. There are a couple qualifiers. Okay, can't be man-made, and it it must flow. Okay, so it's got to be some slope in it. I like this picture. I like this picture a lot because it's really hard to get a sense of scale until you see that guy right there, and you see his towel. You see a little cooler or something there, and hey, there's another person right there. And then, wow, all of a sudden, these rocks are huge, right? But otherwise, you could have just been standing there and taking a picture, aiming down at your feet. It's a little hard to get perspective there. So, any channelized body of water, regardless of size. What does channelized mean? Channelized means it runs through a channel, a ditch, okay? Stream channel. We'll talk much more about stream channels. But first, how do we get there? Well, as I said, it's surface water drainage. And when they talk about how the earth drains, you're basically going from high spots to low spots. And it really depends on the scale that you're looking at there, how much, that could be. So we're going to talk regional, okay? Just change this picture for a minute here. We're going to talk about this regionally. And you see these multicolored areas here. These are major drainage basins, okay? The other word here, divide, you saw it on this slide as well. The word divide is they call it a ridge, I guess. The high spot between each basin. All right, every little drop of water that falls to, that's a little easier on this image. Every little drop of water that falls to this side, okay, of the diagram, of the ridge, it's going to roll down this way. Every bit is going to roll down that way. It's a high spot. Think of it as a roof on your house, standing on the sidewalk or in the street out in front of your house, and you watch it rain. Okay, your roof has a peak more than likely, and all the water that falls to one side of the peak is going to roll down one way. So you understand what I'm saying. So the same thing is true here. Typically, you're looking at mountain chains. Those are great divides. Very famous one out there, the Continental Divide, Rocky Mountains. You got the Appalachians here. But it's not always mountain chains. It's not always obvious why the divide is. But topographically speaking, lay of the land wise, there's an area that's higher and it just separates out into other regions. Now, I don't care with regards to testing. I'm not going to ask you to name these drainage basins and so on and so forth, but just understand that that's how stuff flows. And then when you get down to a smaller area, regionally speaking, okay, let's look here at this nice big Mississippi River basin right here. All right. There's a basin that fills this river. There's a basin that fills that river. And this one, and so on and so forth. So you realize within these bigger basins, there's smaller collecting areas, and it's just all feeding bigger and bigger stream systems. Okay. Speaking of feeding bigger and bigger stream systems, this is a great example. You look back here, and you see a stream. This is a matter of scale right now. It's a function of scale right now. If we were to zoom in on that, okay, we might see something that looks like this. If we were to zoom in even further, that's what this square is representing, well, we realize that it's not just a simple two-pronged fork here. My goodness, look at all the little feeders here. So these feeders that we're talking about are tributaries. Okay, you've heard that word before. Tributaries contribute water to stream systems. Okay, tributaries add water to stream systems. We're going to have another word a little later. It's very similar, but they take water away instead. All right, but right now, just tributaries. And like I said, it's a function of scale. Some folks, again, going back to the topographic mapping lab, they're like, oh, there's a stream down at the end of my street. I didn't see it on the map we looked at. Well, scale-wise, it didn't make the cut. Okay, and if you were able to zoom in a little closer, it definitely would show up. All right, I want to throw a little vocabulary at you here. This is actually a new slide. It used to be called Anatomy of a Stream Channel, and I would always draw it on the board. But for the online folks, it was difficult to picture in many cases. So I tried drawing today on my computer, and it was horrible. So I went out and found an image that gave most of what I wanted, and then I relabeled it in some cases and added some stuff. So here's our stream channel, okay? So the channel, as I said earlier, is the ditch. So we see our vocabulary word right here, stream channel. Here's the channel. Now, as part of the channel, we have two more vocabularies. We have the bed. My mouse keeps disappearing and getting way off course. All right, the stream bed and the stream banks. Well, you've heard of the banks of the stream, and you've probably heard of the stream bed as well. The bed is the bottom, okay? Stream bed is the bottom. The banks are the sides. The banks are the sides of the stream. And I always joke that if you went fishing when you were little with your grandpa or an uncle or an aunt or whomever you went fishing with, they might have said that they were standing on the stream bank, okay, on the bank of the stream. No. More than likely you were standing on a floodplain, maybe the levee, okay, unless your feet were wet. All right, the banks are the side. It's one of those words we misuse. It doesn't really matter much in life, but since it's, in this chapter, we'll set you straight a little bit there. So the banks are technically the sides of the stream. So, got a word here, levee. You've heard of levee. Drive your Chevy to the levee, and sometimes the levee breaks, and a handful of other things. Levees are flood deposits. We'll, again, talk about them a little more in a bit. But they're right next to the stream bank, and they are before the flood plain. What happens to form a levee is during a flood, the water level gets higher, and it washes up over the sides of the banks, as soon as it comes up onto dry land, the water slows down. and because it slows down, it drops a whole bunch of sediment really quick. And that sediment builds up alongside of the stream time after time after time again. And it actually serves to sort of enhance the channel there. It makes it a little higher. And it's sort of natural flood protection, if you would. Streams don't think that way, of course, but that's what it's doing. It makes just that the rim of that makes a little lip on it, I guess, of that stream channel a little higher. Now behind the levee, we have what we call the floodplains. Okay, I don't usually worry about the word active and abandoned too much, but again, since it was in the diagram, I decided to leave it this time because it does explain perhaps a phenomena that you have encountered over the years, where you sort of have this terraced land coming down to the stream. And what, let's go to the higher one first, the abandoned floodplain. What this probably marks was a much higher, older area for the stream, and over time it streams eat into the ground. Hopefully, over time it wore down. So this is its new floodplain here. So what is a floodplain, whether it be an old one or a new one? It's a broad expanse of flat land, as the name plain hopefully implies to you, that you'd find on one or both sides of a stream, and they're flat because of all the sediment washing up. All right, we told you that the levees are flood deposits first and foremost. That's the big heavy stuff, cobbles, pebbles, gravel, whatnot. All right, that falls out because it's really heavy. It's one of the first things to fall out of the water as it washes up over the banks. But the lighter stuff, sand, silts, and clays, all right, they wash more further inland, and they fill in all those nooks and crannies, again, over time, and the unevennesses, and you end up with a nice, wide, flat area. Beautiful land, oftentimes. The problem that we have with that is we're not so smart sometimes, and we build houses, nice, pretty expensive houses, because they've got a great view of the river. And we forget that these are called flood plains. What do floodplains do? Well, they tend to flood, and then we get upset when our nice, pretty houses and all our stuff gets wet. It is what it is. I'd like to think we don't do this so much anymore. If you live in parts of the Utica area around here and Whitesboro and whatnot, you know that in Sequoit, you know that what's defined as a floodplain can change. Areas that didn't used to flood now are sometimes flooding. So it's tough. Okay, it's tough, but some choices are quite obvious. Some choices really shouldn't be choices. So, all right, so just a little review here, a little reminder. We've got the channel. You've got bed and the banks, which are part of the channel. Bed is the bottom, banks are the side. You've got the levees, and then the flood plains. All right, so I mentioned that we'd talk about how levees are formed just a little more, and here we go. Here's your stream on a normal day. Here's your floodplains, and here is one hell of a flood, apparently, huh? Anyhow, what they're showing you here is as this water comes up and again washes over, it slows down. We'll talk about the mechanics of that a little later, but the water goes up and over, it washes down, and then when things go back to normal, you're left with, see how it's enhanced here, you're left with these ridges, and again it's a ridge of sediment along a stream channel is really what a levee is. All right. I mentioned that there's some new slides in this presentation. There's one after this now. It sort of serves as a summary. There's a whole bunch of vocabulary on here, and so if you miss some of it as I'm talking about it, you will see the terms again on the next slide. If you have the handouts printed out, you probably already know that. But all right, anywho, so the first thing we want to talk about, the first word is headwaters here. All right, the headwaters is where the stream starts. It's the beginning of the stream. Headwaters. Okay. We see a bunch of tributaries all through here. Again, what do tributaries do? They contribute to the stream. All right, and I think I said earlier the main stream channel. Well, we've got a word now for the main stream channel. That is the trunk. Okay, the stream trunk or the trunk stream. You hear it both ways. Think back to the Mississippi River basin that we saw. Okay, in that scenario, the Mississippi is the trunk stream. But if you go to any other, any other. If you zoom in, you focus in a little closer, you might find another. What anyone who lives in the area would consider a major stream, a major river. That feeds into the Mississippi, all right, but it itself has many feeders, has many tributaries. So I just want you to realize that it's relative, I guess. Okay, we're going to keep our examples very simple as we can here. Again, a trunk stream or the stream trunk is just the main stream channel that the tributaries feed. But as I said, just keep in the back of your mind that that could be fairly relative. All right. So we got all these feeders. We're uphill, by the way. Hopefully that's obvious here. Headwaters, all this area, the drainage basin is draining into this main stream, and the little stream goes down, and then it hits this lowlands, the floodplain area here, and it's going to eventually empty into a body of water. We could make it a coastline if you'd like. All right, doesn't need to be a lake. We'll make this the ocean. So a number of things happen when the river starts to live on flat land here. It slows down, for one thing, okay? You'll find out a little later some more about that, but when your slope goes away, so does your speed, okay? So the river slows down, just as much water in it though, and what happens is it starts to bend. We call these bends meanders. There's the vocabulary word right there. Streams naturally have some turns in them. Okay, they're very seldom straight as an arrow, as they say. Much straighter when there's a lot of velocity and it's just cutting right through. But again, once it slows down, things tend to happen. Well, one of the things that happen, and I know you're tired of me saying we'll talk about this soon, but that we will get into a little more, is that these bends in the streams really start to get accentuated. All right, they get very extreme, and anyhow, so the river starts to meander. Here's our floodplain vocabulary word again. All right, we're going to skip delta for a moment and go to mouth. All right, mouth is where the stream ends. I don't know why they didn't pick foot or tail or anus, stream anus. No one would want to live there, I guess. But the mouth is where the water is pouring out, pouring forth. Perhaps that's why they call it the stream mouth. So it starts at the headwaters, ends at the mouth. Rather short journey. All right. Often found at the stream mouth is something called a delta. It's named for the triangular shaped letter, okay, delta, and it's actually I don't want to call it a time machine exactly, but boy, a delta represents a huge amount of time. We need you to sort of mentally erase all but one of these little streams here, and that would be day one, moment one, as that stream emptied into this river. Okay. Remember how we told you with the levees, how when a stream slows down, it drops sediment, right? So it's been dropping a whole lot of sediment when it came down here. And now, boy, nothing slows a stream down more than entering a standing body of water. And even if there's waves here, that doesn't count. Um, Compared to the stream, it's like hitting a brick wall. Okay? So what happens, my mouse is gone again. There we go. Is this water comes down and boom, all kind of sediment drops out. And the water washes in, but the sediment is left there. Well, at some point, and again, this takes hundreds and hundreds, if not even thousands of years sometimes, that channel will clog itself up. And what happens is the stream backs up a little bit, finds a low spot, and starts carving through a new one. It carves through that, flows through that, until it clogs it up. And then it moves over a notch, and it moves over a notch. You know those sprinklers? I'm going to make some noise here. You can't see my hand moving, but you know they go. All right. So they make that stuttery noise as they spray, then they go back one long motion and then spray it all over again. Well, imagine if that stuttering spray going on for 10,000 years. Okay. And instead of throwing water, it's throwing sediment. That's kind of how this delta forms. All right. If you had a Western Civ class recently, you might know that we started many of our civilizations at deltas. Okay, they're amazingly rich and fertile areas. The organic material, lovely fine grain, as I said, sand, silts, and clays. All the stuff that lived and died in the river is washed down there. Just amazing soil. Okay. But you know, there's a handful of other issues. We're not going to get into them right now. But if you ever wondered why we set ourselves up on deltas, it's because of good soil. And the cause is, well, what I just explained to you, all the stuff that washing down there. All right, so what did we have? We had headwaters, we had trunk, we had tributary. Oh, didn't talk about that. Hold on. Meanders, mouth, and delta. So I forgot one word, distributary. Let's go back a minute here. I need to make a stream here. Do I have a edit tools? I know there's edit tools here somewhere, but I don't know how to pull them up in this mode. Let's say that there was right here, a little stream that went off this way. Just for whatever reason, the channel split off and just kind of dead ends over here. Or if this one that exists, if that went downhill. Okay. The idea is I'm trying to take water out of the mainstream channel. Up here we were feeding the mainstream channel with tributaries contributing. Well, we want to make a distributary right now. Distributaries distribute water, take water out. Okay. And like I said, they kind of have to be a function of topography. The stream branches off and it removes water from the main stream system. That's all. Not a big deal, but just wanted to get that one more vocabulary word in there. So tributaries contribute, distributaries distribute, remove. Okay, bunch of vocabulary here. All right, told you we'd talk more about meandering. Meanders, as we said, are curves in a stream or bends in a stream. And caused by differential weathering and erosion and deposition. What the heck does that mean? Well, what it means is, I don't want to go to my picture yet. Imagine this picture right here. Maybe I should have snipped this out and put it on the previous slide. But so we're coming down, we're going around a bend, another bend, another bend. All right, so you got a bend here, 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 and here, right? Okay, on each of these turns, there's an inside and an outside. Inside, outside. Over here, outside, inside. inside, outside, outside, inside. All right? Outside, inside, outside, inside, inside, outside, outside, inside. The reason that matters is because on the outside of a curve, you get weathering and erosion. On the inside of a curve, you get deposits. Why? Speed. Okay? What happens as you whip around this curve here, the water on the outside of the bend speeds up just a little bit. The water on the inside slows down a little bit. And remember what we said with velocity, okay, of the water. I've mentioned it a couple times in passing, but it's true all the time. All right. When stuff slows down, it can't carry as much sediment. When it speeds up, guess what? It can carry more sediment. So as it comes around this curve here, it eats away. As it comes down there, it deposits. Well, same thing happens when you go over here. This wears away. This gets deposits. And it takes something. This keeps the meander the same size as it goes through these pictures. I wish it didn't. I wish it would show you that maybe having some pictures before this one where we can see this meander growing. Okay, but what it would do is, oh, I see. They're growing this one is what they're doing. They're moving. I shouldn't use the word growing. Because see, it stays the same width. Ideally, textbook example, it eats out as much here as it deposits here. It basically keeps your same width. All right, but it moves, it migrates the meander. All right, I don't want to get too far. This is about OXBOW, so I don't want to get to this quite yet. So let's go back before we move forward. So what we're telling you is that as a stream ages, okay, its tendency is to increase its meandering. And it does that by taking subtle differences that originally exist in the stream and accentuating them over time. On the outside of a bend, it's going to wear away. On the inside of a bend, it's going to deposit. It keeps the stream roughly the same width, but it moves or migrates the channel, okay, in the direction of the outside bend. So, new vocabulary word, Oxbow Lake or OXBOW. All right. We noticed things like this way back when. Like, this is a really weird shaped lake. What's going on here? Or if you were walking through the woods, because it's so long and narrow, you might even think it was a stream, but hey, wait a minute, it's not flowing. Well, as we climbed up on hills and looked out over mountains, or we started getting aerial views from airplanes, we realized how common this was, and seeing it in a broader perspective, we realized that these were cut off meanders. Okay, this one right here is really about to almost get cut off. This one's pretty close. So what happens, as we were showing you, is, again, this moves this way, this one moves this way. Eventually, it becomes way too much work for this stream to go all the way around the bend, all the way around the bend, all the way back around the bend. It just, whether it's because of a flood one day or these just get so close that they literally just touch, it's so much easier for the stream to flow here. Water, like everything else in nature, follows the path of least resistance. Well, it's going to channelize right down in here, and eventually it's going to stop flowing through there. And what you see then, this brown indicating the fact that it was cut off. Okay, it just dried up. Now, depending on how much moisture, of an area we're talking about here, sometimes these things can swamp in. If you get a lot of water, sometimes it just keeps this one shape. sometimes eventually it'll all dry up. All right. The last thing I want to talk about is this word right here, OXBOW, because everyone knows what an OXBOW is, right? Um, you do know what a yoke is, though. You've probably heard of a yoke, right? That's what it's named after. The yoke that goes around the neck of your oxen to pull a cart or a till for the land. All right, it's named for that. All right, let's stop this here before we get a new topic.